All right, here's the video for how to sketch and find the vertices and foci for this equation here. So our equation is x squared plus 25y squared minus 6x minus 100y plus 84 equals 0. And so our first step is just going to be to group our x and y's together and to get that 84 to the other side of the equation. So to subtract 84 from each side. So here we go. We got x squared minus 6x plus 25y squared minus 100y. And then again, subtracting 84 from each side, so equals negative 84. And what we're going to do here is we're going to complete the square for x and use completing the square for y as well. X already has a coefficient of 1, the x squared term does, and so we don't need to factor anything out. We'll just go ahead and rewrite it as with a nice little gap here. So we'll have x squared minus 6x, let me rewrite that, minus 6x, and then space, plus, and now on the y terms, we need a coefficient again of 1, and so we're going to factor out a 25 from each of these two terms. So 25 times, which leaves us with y squared minus 4y, and again, going to leave a little blank here for the term that we're going to add in for completing the square. And that's all still equal to negative 84. All right, now we get to use completing the square. So what term we're going to have to add in here? Well, it's half of negative 6. That's negative 3. And negative 3 squared is positive 9. So that means we're adding 9 to the other side as well because we've got to keep it equal. Here we're going to take half of negative 4 divided by 2. So half of negative 4, so negative 2. Square that, which is plus 4. But we need to make sure that we remember we're actually adding 4 times the number out here. So we're distributing 25 across this, meaning when it gets to that 4, it's really adding 100 on the left side of the equal sign, meaning we need to add 100 on the right-hand side. Be careful, because that's a place that folks usually can get tripped up and just make kind of a careless error there. So again, we're adding, the number we're really adding here is plus 100, because we factored out that 25, and that 25 multiplied by this would be distributed in, so give us a plus 100. All right. So we did all that so that we can write these as perfect squares. So we're going to have x minus 3 squared plus 25 times, we're going to write that, plus 25 times y minus 2 squared. And that's all equal to, well, negative 84 plus 100, that's positive 16. And then 16 plus 9, that's 25. So equals 25. Here, we're going to divide everything by 25, because remember, we want this equal to 1. So when we have the equation of an ellipse, we want it equal to 1. So divide everything by 25. And we're at x minus 3 squared over 25 plus, and 25 divided by 25 here is just 1. Those cancel out. So y minus 2 squared over 1 equals 1. And I actually would put the over 1 for the y squared, just to remind ourselves, because remember, this is our going to be our vertical, how much we're moving up and down. That's our a squared or b squared term here. So we do want that over 1 to help key us in on that. So what is the center here? Well, the center is going to be at 3, 2. There's our center. And so 3, 2. There's our center. Now we need to find our vertices. And so the square root of 25 is 5. So we're going to go 5 to the right. 1, 2, 3, 4, 5. Oops, it's a little bit off. Let me try that again. 5 to the right and 5 to the left. 1, 2, 3, 4, 5. Vertically, our vertices are going to be at the square root of 1, which is 1. So up 1 and down 1. Now to find our, actually we can go ahead and put in our vertices now. We have vertices at negative 2, 2. Negative 2, 2. And what is that? 1, 2, 3, 4, 5, 6, 7, 8, 2. We also have, those are our vertices along the major axis. Our vertices along the minor axis are going to be 3, 3, and what's this other one? 3, 1. There's our vertices. Now we need to find the foci. All right, so sorry about the interruption there. We now need to find the distance from our center to our foci. And remember, the distance from the center to the foci squared plus the distance from the center to our vertices along the minor axis squared is equal to the distance from the center to the vertices on the major axis squared. And actually, typically we'll count the distance to the foci as c squared. But the longest distance is equal to the other two distances or lengths squared. So let's find those out. So our major, the distance from the center to the vertices on the major axis, that's 1, 2, 3, 4, 5. So 5 squared. I kind of carve out some room right here. So 5 squared is equal to, let's put it on the right, 5 squared is going to be equal to, well, the distance here on the minor axis is 1 squared. So that plus our distance from the center to the foci, wherever that's going to be, is going to be our c squared. So we've got c squared plus 1 equals 25. Subtract 1 from each side. We have c squared equals 24. So c equals the square root of 24, which is just more than, which is almost 5, but not quite. It's more than 4, less than 5. And so our foci are going to be out around here a little bit. Now we can kind of finish the sketch of our graph. Not a very good sketch, I'm sorry. Something like that. This needs to go out all the way to that vertex. There we go. So not the world's best sketch, but hopefully you get the idea. So where specifically are those foci? Well, they're going to be, and you can simplify the square root of 24. That does simplify down a little bit, but we'll just leave it as it is for right now. It's going to be at the center, which is x equals 3 minus, so 3 minus the square root of 24, comma 0, or comma 2. That's the y value there, and 3 plus the square root of 24, comma 2. All right, hope that helps.